give those guys a hand. Hey, sweet. What was that? That was the song that would never end. Was that what it's called?
The song that never ends.
The song that never ends. You guys are getting good as you get older.
We get paid by the minute.
You get paid by the minute. Well, that's the way it is. Hello. Are you there? Hi. I'm Jake Wizard 4, and welcome to. Let's hear. I'll say it one more time. I got to get my bell ringers. I'm Jake Wizard 4. That's right. Every time you hear the word wizard, Faraday Studio, a bell rings. I don't know what causes it. It's something mysterious, but it just happens. And here we are we're live on YouTube. Is that where we're at? Nobody knows. I don't know how we're getting to it. We're sending you the vibes. I don't know. But we're on YouTube, I think. And I would like to welcome you to Faraday Studios, a home of Midnight Science Club. And today, we're doing something special. We just did an event with the Science Olympiad, and we had a competition, the Science Star Search. Science Star, it's got 3 S's in it, isn't it? You know, Science Olympiad, Science Star Search. That's the SOSSS. I guess we just did that. And we're going to interview some of the winners of that competition. And this has special meaning to me because I'm Wizard and I'm getting old, and we're looking for a replacement wizard down the line. And we might have some of them here today. Oh, please. And it's old. Okay, so let's get started. Here's what we're going to do. We're at studio, and you saw where we're at. It's kind of a cool place to be because where all the wizards hang out. Yeah, you guys are getting good. This is great. So what we're going to do, I'm going to interview the four of the 6 finalists that are here today. They're with us. 4 of them are with us. I think the better looking ones are here today. Is that what it was? Was this a smart group or the better looking group? Oh, they're both. Okay, never mind. That didn't work. I'm going to interview them, and then we're going to look at a little video of each one. And then at the end, as we always do at Faraday Studio, we end with a bang of some sort. We have to blow something up or do something, you know. But before we start, we got a couple of guests today. Now, everybody think of NASA. What does NASA stand for? N-A-S, National Artichoke and Sausage Association, or something like that. NASA, something like that. I know it's full of ham. Dr. Bob Starr. Are you there, Bob?
I'm here, Jake. National Aeronautics and Space Administration. I don't think there are any artichokes in there.
Yeah, and all these scientists. And Bob you're retired now at NASA, but he was a big shot there at NASA for quite a while. And I met you at Langley Research Laboratory? Is that where I met you?
Langley Research Center in Hampton, Virginia. Yes, Jake.
That's where all the secret stuff was, man. Langley. So Bob is actually the executive producer, one of the executive producers of everything we do at the Faraday Studios. He's one of the men. And you've been in media for how many decades?
Oh, 50 years, Jake. I've been
you're back with Black and White TV, weren't you? Black and White TV, 2 stations. You've been around. Yeah. And did you go up on a space shuttle? They wouldn't let you on, would they?
No.
They didn't let you on. But anyway, Bob is our NASA contact and presence, and he's with us today, and he helps us so many ways. We wouldn't be here if it wasn't for Bob, Dr. Bob. We also have I guess you would say she's our celebrity friend, Tamara Robertson, and I saw her on Mythbusters. I worked on Mythbusters too, but long before she got there. And so you're a Mythbusters gal, but you're also a scientist, right?
I am. I'm a chemical and biomolecular engineer as well. So I do that during the off season.
Do that, and then you hang around at Faraday Studio and do general honoriness with us on the side. But yeah, you were on Mythbusters, and you did you did Mythbuster Kids? Did you do that too, or which ones?
Yeah, we did Mythbusters The Search, Mythbusters, and then Mythbusters Junior most recently with Adam Savage and 6 kids from across the nation.
And now you've moved to the top of the heap, and you're at Faraday Studio doing this. This is great. Nice to know we're at the top of the mountain.
Amen.
You know what I'm saying? Tamara's going to help me. You're going to help this interview today, right?
I am.
Thank you. So those are our guests, and we've got some people up in the balcony. Can you switch a shot up there? We have to keep them locked up there. We just have people come in and visit. You got a shot of that? Everybody wave up there. Hey. You guys didn't enter the competition, did you? No. So you didn't win. You didn't get any of the money either, did you? No. Too bad. Okay. But they're here. They're good Midnight Science Club members. So I think what we're going to do is we said hello to the guests. Okay, we did that. And I've got to talk to the people who are watching us online, we want you to send us questions on the chat spot there when you're looking at it. Say, send us some live chat. We want and send us questions, and then later on in this little group meeting here, we'll answer your questions. So if you get a question, put it on the chat, and we'll talk to you. Okay. The first person we're going to introduce is Adia. Where are you at, Adia? Come on up here. Pop her up.
Hello, thank you for having me.
There she is, up in the upper right-hand corner. She scared me. So, do you remember what you did in this competition? You know, we sent out, how many did you have to choose from? You had, was it 4? 4 activities we challenged you with, do you remember?
5.
Oh, 5. It was 5? 4 or 5, and you had to pick one of them, correct? Can we hear her?
Hello?
Yeah, you can. You got to talk. Yeah, you have to talk so I can hear you. I don't even know it. There you go. Thank you. So, what was the demonstration you did? Do you remember?
I chose the demonstration regarding static electricity fleas.
Yeah? Static electricity fleas. So what did it do? What did you do with static electricity fleas?
So basically, I did my demonstration with my little sister. So I used her hair, and then I also used a balloon and some ice puffs. And so I demonstrated the physics concept of static electricity by demonstrating the transfer of like charges from one object to another.
Yeah, sweet. So you kind of, we gave you some instructions and you kind of ran with those and came up with a novel way of presenting them, right?
Yes.
Yeah, that's what you did. So did you get any help doing that? Was that all pretty much you?
Well, my mom helped because we actually don't have a tripod, so she had to like stick in and film the video for us. And then obviously my sister, we needed her patience because she's 10 years old, so she was getting irritated because I was like rubbing her head again and again. Yeah. So yeah, I had both of them.
Tamara, do you have a question for Dia? Did we lose Tamara? Earth to Tamara now. Yeah, there she is.
Sorry, all of the presentations had to be an uncut 90 seconds. Was that hard to compress your demonstration and your explanation down into that 90 seconds, or how did you go about making sure it fit?
It was actually really challenging being able to film the video within 90 seconds. So I went about it by kind of laying out all the key concepts that I felt needed to be included in the video. And once I did so, I tried to make the video as engaging as possible without kind of just throwing concepts out there. So I tried to tie the concepts regarding static electricity back to a real life situation. And I had to film it like a multitude of times because I kept going over the time limit if I said like one So it was really challenging, but in the end it worked out.
Well, let's just see what you did. Let's see how you did. She's a good science communicator. She's a good communicator, but let's see how she did. We got a clip of what she did. Let's see it.
Hi, my name is Dia, and I choose the topic static electricity fleas for my demonstration. Have you ever walked out on a winter date and touched the car door and you feel a zap and then you say ouch and your mom responds, don't worry, it's just static electricity. Well, what is static electricicity? I'll be demonstrating that with my specimen, my little sister, this balloon, and some rice puffs. So I'm going to take this balloon and I rub it against my little sister's hair. We see that her hair attracts to this balloon. Why is that? Because the electrons from her hair goes to the balloon, and as a result, the balloon takes on a negative charge and her hair takes on a positive charge, and opposite charges attract. Also, her hair flakes out as each individual hair particle repels from each other due to all the positive charges. So if I take this balloon, which is relatively negatively charged, and I hover it amongst the rice puffs, we see the rice puffs move up and down, up and down. The rice puffs attract to this balloon as the rice puffs have a positive charge in comparison to the balloon, and the balloon is negative. Once the rice puffs are attracted to the balloon takes its negative charge and transfers it to the rice puffs, and as a result, the opposite charges repel from each other, and the rice puff goes back down. Once the charge disseminates, the rice puff moves back up. In conclusion, referring back to my analogy, static electricity is the buildup of electrons from the jacket to your body. The electrons cling onto your body due to the dry air during winter. The electrons flow from your body to the car door when you touch the car door, and as a result, a circuit is formed and you feel a zap. Thank you.
Wow. Let's give that girl a hand. You're pretty good. Yay! And so for your effort, the judges said you did a good job, and you got a little cash award coming, don't you? The question is, do you have to share any of that with your little sister?
Yeah, I have to give her half.
Oh gosh. I don't know. I don't have a little sister. My little brothers, I'd give them $2. Well, good for you for being graceful to sharing with your sister. That's sweet of you. Thank you. You did a great job. Thank you very much. We got to move on, though. Oh, I got to remind the audience, send in questions, because I'm asking all the questions of Tamara. If you've got questions for them, make sure you put it in the live chat, and we'll get to it in a second. So our next person that we're going to pick on and celebrate is Anson. Are you there, Anson?
Yes, hello. Thanks for having me.
I'm glad to have you. Yeah, oh gosh, where are you from today?
I'm from Minnesota, just
Minnesota.
A small suburb.
Yeah, really? How do you spell Minnesota?
I
got him. That's how you have to go. We got you. I do that. That's a true. Does anybody here know? Don't say it. Anybody here know how to spell Minnesota?
M-N.
M-N. M-N. That's all you have to know. So, Anson, what did you do?
So I did the washer stack experiment, except I modified it a bit with poker chips instead.
Did you really? I like that. That was really sweet. And where did you come up with the idea for the poker chips?
Well, the poker chip idea actually came a while back. I think it was like maybe 5 or so years ago. I was at a Boy Scout camp.
Yeah.
And we were just playing cards, and someone decided to show this trick with the poker chips. And so I thought I'd just take that idea and expand a bit on it.
So is that what you did, that creative part? Is that part of being a science communicator, being creative? What do you think?
I think it is. You need to be creative and to express your ideas in new ways that'll get people invested in what you're saying. Probably is one of the better parts of being a communicator.
Well, you're a good one. As a matter of fact, what place did you come in the competition?
I came in third.
Third. That means you're pretty doggone good. Third place isn't bad, is it? You got any plans for the money?
I was thinking sort of putting it off for college, just to help fund large
keep a little
college
out
fees.
for a pizza or something. But go to college. That's cool. Sweet. Tamara, do you have a question for Anson?
Yeah, I do. So you took your demo a step further too and added in the multiple stacks. Mm-hmm. And so obviously you had the time constraint, you had to get all of your science in, and you're trying to do this flare. Was there any problems with having it actually happen every single time so that you could get it all in one take, or did it work seamlessly each time?
There were definitely multiple takes that we needed. I counted after we finished filming it all. It was 28 different takes, and only the last one did it work right.
28?
Either a chip would fly off at the wrong time or the stack would fall over. It was a mess until the very end.
Well, that's not bad. At least the man's honest.
We call that, oh, sorry. I was saying in science communication, we call those the practice runs. Then.
Practice runs. Well, I think that's a new record, 28 takes. That's pretty good, man. These guys here won't give us 28 chances, will they? He gives me 2. They call me One Take Jake. There you go. But congratulations for coming in third, Anson. That's great. Let's see what he did. I want to see this poker chip thing. Let's see this.
Here's a bet you can try with your friends.
Oh, look at that necktie.
Coins, walk
That's
through,
sweet.
in this case, poker chips, and set them up on a table like so. Challenge them to try and remove the bottom chip in the stack without actually touching the stack. It may seem impossible, but with the power of science, it can be done. Observe. So how does this work? Well, in one word, inertia. Inertia is a property of matter which causes an object in motion to stay in motion and an object at rest to stay at rest, unless acted upon by an outside force. In this case, when our poker chip collided with the stack of poker chips, the stack tried to stay at rest. But because of the force by that poker chip enacted upon the very bottom poker chip, it caused it to go flying. Now there is a second property at work here called momentum. Momentum is the mass of an object multiplied by its velocity, and there's a property in physics called the conservation of momentum, which states that the total momentum of a system must be conserved. There's a second demonstration set up here to demonstrate that fact. Here we have a poker chip, and we're going to use this to hit the first stack. by the conservation of momentum, this final poker chip should fly off after a series of reactions. Let's take a look.
Look at this. Oh my God.
And there it goes.
There it goes.
Thank you for watching.
Man, 28 takes. I can see why. Get him in a hand. Sweet. I think we're going to steal that idea. That was pretty good. So, did you ever get all the poker chips to behave, the whole transition from one end to the other? Did you ever hit it perfect?
I think out of all the takes, it probably happened maybe 6 times.
Well, there you go. That's not bad, man. I would do it the first time every time because I'm the wizard. You know, that's the way it is. Well, thank you, Anson. That was sweet. And enjoy your prize. That was something. Well, listen. Oh, before we go on, I have to remind everybody that you can see what we do. You can join us and be a follower with us on Instagram and YouTube and Facebook. That Midnight Science Club can be found on all those. And we get together like this all the time and work in the science communication community. And there's a lot of friends and people all around the world who join us. So, Anson, you're now an official member of Midnight Science Club. And we're going to steal your idea of the poker chips. It'll be great. Well, listen, let's move on. Let's see who's the next person we've got. It's somebody named Dana. Donna. It's Donna. Did I say Dana? Dana and Donna. I can't read my own writing. Donna, are you there? There she is.
Yeah, hello. Thanks for having me.
So where are you today?
I'm in Ohio.
Really?
In my house.
You're in Ohio. So that background is not your wallpaper in your room there. Nothing like that? Well, pleased to meet you. And so did you belong to a team, a Science Olympiad team?
Yeah.
Where'd you go to school? Is it a school team?
Yeah, it was a school Science Olympiad team.
Okay. And did you do well with the Science Olympiad this year, or did you, I guess you didn't go, or did you do local stuff, or what did you do?
Well, for me, Science Olympiad got canceled right before regionals.
Yeah.
But I was doing okay, pretty well till then.
Yeah, there you go. So you consider yourself a science communicator? Think you did a pretty good job? I guess you did. What place did you score in this competition?
Second place.
Second place? Goodness sakes. What's the prize for second place?
$1,500.
Oh my gosh. Can't you keep from smiling? He's smiling. Yeah, $1,500 would make me smile too. That means you must be a pretty good, you know, those judges we had, pretty tough judges, weren't they? You know, you came in second place, so you should be very proud of that. Did you have to rehearse that very many times when you did it?
Yeah. I even had to write a script and somewhat go off of that to make sure I was in the right time frame.
Oh, did you tend to want to wander like I do? Go off sideways and talk too much? Go the wrong way? You have to write a script, huh? Don't you guys pay attention to that? Everybody in here is nodding. Follow the script, yeah. Tamara, do you have a question for Donna?
I do. So if you're writing a script with it, how did you decide what you wanted to include? Because I noticed you included a lot of real-world applications as well to kind of emphasize your scientific principles. So how did you go about selecting those?
Well, when I was going through my research, first on my script, I wrote down all that I researched, and then I cut out certain parts of it by importance. And I also watched other science communicators' videos to help me get ideas to make it more interesting, like Bill Nye, for example.
Oh, really? You mean you borrowed ideas from other science communicators?
Well, not necessarily. I watched their videos, but I came up with.
See, I would never do that. Tamara, would you ever do that? Would you ever borrow ideas from other science communicators?
I think that there's a lot to be learned and a very ease of iteration when you can look at professionals in the field of science communication and see what they do well and what they can have improvements on. So I definitely pay attention to what other science communicators are doing in the field, mostly because I learn just as much as the people that watch them.
That's right. That's right. I was joking around a little bit. Of course, we borrow ideas all the time. As a matter of fact, we're always trying to get into each other's head. Like we just got one from Anson that doing the poker chips in a line like that is a sweet idea, and I'm going to be using that thing. So that's we do that all the time, Don. I was just picking on you a little bit. Hey, let's see what. By the way, Don, which project did you do? Which activity did you do?
I did the balloon gyroscope demonstration.
The balloon gyroscope. Can we watch you do it? Let's see how she did. Let's watch it.
Have you ever wondered how bicycles always stay up in the same upright position when in motion? Or how about how pilots know exactly how many degrees to turn their planes? Well, all of this can be explained through the utilization of gyroscopes. So what's so cool about a gyroscope? Well, a gyroscope is a rotating device that can be used to measure and maintain orientation. Basically, a gyroscope is a spinning thing. Just like Euler's disc, this fidget spinner, or the ball in this balloon. This system is a gyroscope because as the ball rotates, it mimics the Earth's planetary movement about the sun. So back to our original question, what is so cool about a gyroscope? Well, since the ball is rotating, it has angular momentum. The angular momentum of the ball depends on the mass distribution of the object and the angular velocity. So basically, the faster I move it, the more angular momentum it'll have. Since it's moving counterclockwise, the angular momentum has an upwards vector, whilst if it were moving clockwise, it would have a downwards vector. Note the orientation of the ball. Even if I tilt the balloon, the ball still keeps the same plane of rotation. This is because, from the ball's perspective, it still sees the same smooth interior of the balloon that provides us the centripetal force to keep it moving in a circle. And due to lack of external torque to change the ball's angular momentum, which is why angular momentum is concerned. So there you have it. That's what's so cool about a gyroscope. It's able to keep the same orientation no matter what.
Let's give that girl a hand. That was sweet. Hey, Tamara, we better watch out. This girl's going to be after our job. You know that? You're good.
I think so. Yeah, I definitely think so.
Man, she just talked a stream. That just came out of her. Man, don't let anybody know who she is or where she's from. We're to protect ourselves. Hey, by the way, Tamara, like we say, we like to end every Midnight Science Club gathering with a bang or something spectacular. I got something sweet, and I don't know if you've seen this one. Maybe you have. Have you ever seen the Methane Mamba?
Ooh, no, I haven't.
Okay.
I'm sure I haven't seen it the way you're going to do it.
That's right. So we're going to do a Methane Mamba here right after our last interview. So we're going to do that. Well, speaking of our last interview, let's move on. Jacqueline, are you there?
Hi, yes.
There she is. How are you, young lady? And where are you calling us? Where are you meeting us from? I guess, where are you right now? What am I saying?
Right now I'm in California, just in my workspace. So,
yeah, really sweet. So she's in California. We had two. Let's see, what did we have? We had two from California, Minnesota, and Ohio. Bob's from Atlanta. We're in Cambridge, I guess, where we're coming from, and La La Land. And Nick, I guess Nick, you don't know Nick. Nick's our producer. He's hiding someplace. He's in Florida. We got people all around the world together with you. So which activity did you do?
I did the washer stacker demonstration, and that actually kind of drew my attention because the way it looked, almost like a magic trick.
Yeah.
And that's actually what inspired my whole ninja theme in my video.
Really? Are you a ninja?
I don't do ninjutsu, but I have practiced taekwondo for the past 8 years.
Oh, yeah, that made sense because you move so sweetly. I understand. We're going to see that here in a minute. So, had you ever seen that demonstration before?
No, not in that way. But what inspired me, I guess, was I'd never seen it before, but I thought the scientific concepts behind it were really cool, making it almost like it's defying physics or defying reality. So. Wow,
sweet. And how well did you do in the competition?
I received first place.
Really? Let's give this girl a hand. Sweet. This year's champion. My gosh. Well, you'd have to really do good to beat what we've seen so far, so you must have. We'll have to see in a second. Tamara, you got a question for her?
I do. So since you are our first place winner, what do you think is the most important part of being a science communicator?
Oh.
I would say it's being able to answer the question, how do I hook my audience and how do I keep them interested so they can learn in a fun way? Because a lot of people can explain things, but being able to explain things in a way that captivates your audience is where the true learning happens. And that's actually like, this kind of Midnight Science Club reminds me of my second grade teacher, actually, who first sparked my interest in science because of all her hands-on demonstrations and making science and learning fun for us.
Sweet. You know what? We just witnessed a science communicator. You communicated talking about science communication quite remarkably well. No wonder she got first place. That's amazing. I want to see this first place bit. And this is inertia. This is an inertia demonstration, right? Mm-hmm. Okay, let's see this.
Hi, my name is Jacqueline. And do you want to be a ninja at home? Then check this out. So what was that piece of ninja magic? That was thanks to the science of inertia. Inertia is a property of matter that keeps an object's motion unchanged. Stationary objects stay still, and moving objects keep going. This changes when an outside force is applied, such as friction, gravity, or another object. And all of this is summarized as Newton's first law of motion. So what's going on with the coins? As I use my knife to apply force to the bottommost coin, the inertia of the other coins keeps the stack largely intact. However, you may notice that the stack's shifting around a bit. Why? Friction. The movement of the bottom coin and the impacts from the knife influence the coins above the bottommost coin, resulting in this tilted stack you see. In a frictionless world, the shape of the stack would remain virtually unchanged. So what's the secret again? Inertia, the property that keeps an object's motion unchanged unless an outside force acts upon it. Thank you for listening.
Oh my gosh, oh my gosh. Well, we might as well just stop here. I have nothing else to say. That was incredible. Well, congratulations on winning the competition. I guess you are a science star. We can end the search now. Congratulations, Jacqueline. I appreciate that. You should be great.
It's an honor.
Oh, it is. You're smooth. Are you the same person that was in that video?
Yes, I actually have I still have my ninjaku with me right now.
Okay, just checking, because you've been smiling at me. That girl looked pretty tough in that picture, you know, doing that. So it's the same person. Okay, sweet. Well, congratulations. You did an excellent job. And all the wizards that have, at Faraday Studio, we've been doing this for 200 years, science communication. And we're always looking for bright, new, young science communicators. And you've got the gift. Well, all of you do. Right, you all did. It was a tough battle. So congratulations to all of you that entered, and hopefully we'll do it again next year. Are you going to do Science Olympiad next year? Going to be involved with that? You going to keep doing it? Put your head up and down. Say, yes, sir. Yeah, we're going to be in charge of that. Yeah, we're going to be. Bob, you want to Science Olympiad next year?
I hope that we're able to travel a little bit. I would love to see the kids face to face and enjoy their science communication and all that happens at the Science Olympiad National Conference.
Yeah, I think it's in Arizona, University of Arizona next year, I think is where it's at. We'll have to find that out. And we'll say thank you, Jenny Kopak at Science Olympiad headquarters. She's the CEO, and she helped us put this together. So everybody say thank you, Jenny. I tell you what, to my 4 finalists and to Tamara especially, I'm going to do a science demonstration right here in the laboratory at Faraday Studio, and this is an old one. And I was just pulled over here. I'm going to see if you can figure out what I'm going to do. I'm not going to do this like I'm not going to try to teach you the science behind it, but I wanted to show you this activity and see if you can figure out, just the four kids and Tamara, what this is a demonstration of.
That's a great plug, Jake, but I think we have some questions on YouTube.
Oh, we have some questions. Yeah, hold it. Never mind. I got to go back. See, I made it all the way through with no mistakes. We have some questions online. I asked everybody to send them. Okay. For any one of the 4 of you, what was the biggest difference between speaking live and filming a video? Anybody want to take that one? Raise your hand. The difference between speaking live and then having the camera on. Okay, Jacqueline, what do you got?
I would say, so on the camera, it feels a little more awkward because there's no one, there's no one you're speaking to directly, but at the same time, it's also kind of like you know that you have a chance to do it over. But speaking live, right now it feels more like a conversation, kind of, like naturally talking to someone.
Yeah. Well, you just did. You were just talking on camera, and it just like it was natural. I mean, that's really cool. Anybody else want to answer that one, or should we move on to another question? Anybody else want to add to that? What's the difference between? Yeah, here we go, Donna.
For me, you'd think it would be comforting to speak like recorded, because you have do-overs, but I actually feel more comfortable when it's live, because like Jacqueline said, it is more like a conversation.
Right.
You don't really have to think as much.
What, you don't have to think as much? See, now you folks, you got to quit making fun of me. The girl said it's okay if the presenter doesn't think so much. They make fun of me here because I'm an old man. But see, the young girl says has the same deal. It's pretty sweet. Oh, let's do another question. Do we have another question, Jake? Yeah. Here it is. So we'll get a couple of other people to answer this. How do you keep your excitement level so high when speaking to a camera? How do you keep that? Anson, well, how do you keep your excitement level high?
I guess with this.
Oh, did you drop off there? Hang on a second. We're going to get you back. Is he back yet? I think we lost you there. Just hang on a second. Your excitement was so great you burned up a wire. I don't know what happened here. We'll figure it out. Is he back up yet, Jacob?
Looks like it's more stable.
Okay, can you start over? Start over. Sorry. How do you keep yourself excited?
With this from the one that I made for this competition, as I said, it's based on a memory that I had back in Boy Scouts. It's something that I've kept with me for a while. But I guess when I'm communicating other topics, it's just something I'm passionate about. And like whenever I try to teach someone, it's always in a subject that I know I'm confident in what I'm talking about. So when I try to explain it, I can give it with a bit more excitement because I know what I'm saying will be factually correct, so I can add a bit of entertainment to it.
Sweet, that's sweet. You hit it right on the head. Yeah. Who else? Somebody else? Yeah, there you go. There she is, Dia.
It's Dia. Also, I've been doing debate since 6th grade, so I've kind of just over time developed that skill to engage my audience when I'm speaking and speak like I'm passionate about something, and that's usually where the excitement comes from, as Anson said.
Sweet. So they have different techniques, but drawing from their background sounds like a good one. I always keep M&Ms handy right here. And you know, there's something that all science communicators need to know. When you get in front of the camera or work in a studio or on a stage, it's like being a soldier sometimes, where you have long periods of boredom and monotony punctuated with terror or fear all of a sudden when the camera comes on. And then you go back and you're bored for a long time because you're drinking. And that just wears a human being out, going from long bits of boredom, and then all of a sudden you're on. And that's something that all science communicators have to learn their own little tricks to overcome. Do we have another question? Here it is. Oh, now what, is this one pointed to me? Seems like they're always picking on, all these questions point to me. How do you stay motivated after so many failed takes on camera? Tamara, you're going to answer. Let the kids answer first, Tamara, and then, yeah, go ahead. So one of you guys want to try it? How'd you stay motivated, Anson?
So with the motivation part about taking takes, like with this skit, it's just something that I love doing, is just doing demonstrations for people. And especially that last part, I love the multiple chain reaction. I just really wanted to get to it. But after every failed take, I'd always just sort of make a joke to myself, well, we're going to get it next time. Third time's the charm. Or
well, there you go. Third time's a charm. And then I'm terrified because he just went,
20th charm. We'll get there.
You froze on us there for a second, buddy. That's great. That's a good answer. Well, that was our last question, wasn't it, Jacob?
That is.
That's enough. We have to move on because I'm getting anxious to blow something up here. So I tell you what I'm going to do. You want to help me roll this over? We got a volunteer from the audience. He's masked with goggles, so I don't recognize him. Let's roll this thing over here. See if you recognize what I have here. That's close enough. Yeah, thanks. I'm going to pick up this tray. Hey, back it up just a little bit. There you go. There we go. Sweet. All right, I'm going to point out what I have here. I've got, we're speaking professionals. This is a professional thing. Science communicator to science communicators. Everybody else can take a nap now because we're going to do this together. And this is the old wizard. From this activity is over 100 years old, okay, and I've got an old stand-on. Now I'll just point out what I have, and then I'm going to see if you can figure out what it is I'm trying to do. I've got a water bottle, and I cut the bottom off the water bottle right there, and it's upside down, and I've got a rubber stopper with a little tube, a hollow tube sticking up through the rubber stopper, and it comes up about halfway. And I pinched it down to make, instead of having a big round hole, it's got a little tiny hole like that. And this is just distilled water, any water with a little bit of detergent in it. Do I have some? Yeah. I think in a whole beaker full of water, I put 7 or 8 drops of this blue dishwashing liquid. So it's not much soap at all. Doesn't take much. Got that in there. And you can see this, I've got a rubber tube connected to this tube right here, and it goes all the way around over here to a tank of methane gas. Here it is. My friend methane. Me and methane have been buds for a long time. We've done a lot of science activities together. So I'm going to turn on the methane. And, oops, there we go. It burped there a little bit. So hopefully methane will travel down through this tube and bubble up through that soapy water over there. So I'm going to turn on the gas. If I can find the screwdriver. I don't know. Here it is. They want me to do all these safety things, be safe. I don't know why, but do you have your goggles on? Because you're going to have to help me a little bit. What's your name?
Memo.
Because I really don't want to know your name in case we have an accident. In case we have an accident, everybody say goodbye.
Goodbye.
Okay, just in here. Shake hands. Okay, gotcha. There we go. So I'm going to turn on the gas just a little bit. See, I've turned on the main valve. It says 2,000 psi. That's a little too strong. So the regulator has got it down to 0, and I'm going to start bubbling some. Oh, there we go. Yeah. So now I've got some methane gas bubbling through that soapy water, and it's coming up the tube. So what I'm going to challenge you to do, learn a little science, the 4 or 5 of you. What are some of the properties that this little thing demonstrates about methane gas? And don't have to answer, I just want you to think, what do I now know about methane gas?
It's flammable.
Well, does this tell us that? I mean, just from what you've seen here.
No,
Even though it is, of course it is. But we don't know that because this doesn't show it. What does this demonstrate? Anything? And that process, I love it. The process you're going, put your hand in your chin, and you're going, what does this demonstrate about methane?
It's lighter than air.
Lighter than air, or maybe what's the proper term, scientific term? I'd say lighter than air.
It's less dense, more buoyant.
Yeah, less dense, more buoyant. Yeah, it's more buoyant. Does methane react with water? Is this an exothermic reaction? So methane probably doesn't explode when it touches water. I figured that out, didn't I? Yeah. I'm going to speed this up. Do you see what's coming up out of here, this long thing? And I'll get a little more gas going. Make it go a little faster. Yeah. So how could I demonstrate that this actually is less dense than air?
I suppose cutting it off.
Sweet. Isn't that sweet? I cut off a little piece of it. Whoop, there she goes. Wah-ha. I could sit here and do this all day. And you know what we call this? We call it a methane mamba. Why do you think I call it mamba?
Because it looks like a snake.
I'll blow on it a little bit. Watch it.
When you cut off a lot, it looks like
There, there it came back down. Hey, now you want to get the lighter? I'm just going to cut off a little piece right here. And let's come right over here. And you got a lighter? Come around over there and just come around this side. Let's see what happens here. Oh yeah, sweet. That's sweet. So what's going to happen when he brings that lighter over here? And you guys ready to shoot this? Okay, bring your lighter over here. Everybody say goodbye, Jake, in case we have an accident. Now I'm going to cut it off, and then you're going to light it, right? So get your thing lit. All ready? Here we go. Let's try it. Go. Oh, that's very good. Very good. Let's do it again. Oh, you know what I discovered? If the bubbles aren't the right size, this can get too heavy, and it goes down. Well, welcome to the Methane Mamba. There we go. Yeah, and methane is more dense than air. So this is what an old wizard does for fun, you know. Were you impressed with my Methane Mamba? I wanted to let you guys do this for the competition. They wouldn't let me have you. I don't understand why they would do that. Well, listen, I could sit here and play with this. Is there anything else you'd like to see me do with this while we've got it? What else should we do? Can you think of anything? If you had this to play with right now and piddle with a little bit, what would you do?
cut a large chunk off.
Do what was that?
Cut a large chunk off.
We'll cut off a large chunk of it? I'll cut off this large chunk right here and put it right in front of my arm. And you want to set that thing off? Sweet. Sweet. Okay, there you go. There we go. Well, listen, thanks so much. And make sure, I'm talking to everybody that's watching us on YouTube, that you can join us at all of our Midnight Science Club activities. And we get together once in a while and do live things, and we share these activities all the time because we all have a love for science communication. I want to thank you, and thanks Science Olympiad, and thanks to 4 of you for sharing. I hope you have many successes. You stay in touch with us, and when it comes time to go to college, we'll write a nice scholarship letter for you saying what a great science communicator you are. Tamara, do you want to say anything to everybody?
I just want to thank everyone for sharing all of your amazing loves of science and your science communication skills, and for setting the bar really high for next year's contestants.
Yeah, we're going to do this again, I think. So follow us on Midnight Science Club. We'll see you guys later. Let's have some music. Light it. Yeah, I'm going to turn it off.
Light it?
Yeah,